Welcome to the workshop. Today I want to take a look at differentiation. So this is just a review, hopefully relatively quick, and I'm going to present it in essentially 3 videos. So in this video, what I want to do is I just want to recall the idea of the derivative or how it's first presented. And essentially what it is when we talk about the derivative of a function, we frequently initially consider the graph of the function. We talked a little bit previously about the fact that a graph is only a representation of the function. It's not a function itself, right? So the thing versus the thing that's representing it. So a graph represents a function. So we consider a tangent line. And that's where we initially discover a tangent line, slope of the graph. That's where we initially discover derivatives. So let's take a look at some notes really quickly for that. So again, the idea of the tangent line is that if we have a function, let's say it looks like this for simplicity, and we have some point A, and the output f of a for our function, somewhere right around there. What we would like to do then is consider a secant line. So a secant line is just a line that passes through 2 points. So if I pick some other point over here, some other x value, let's see, the output is about there, and that's f of, well, if we just call it x, then we can do that, and we'll use that in just a moment. And then the tangent line itself, or sorry, the secant line is the line that passes through those 2 points. Remember that we have y equals mx plus b for the equation of a line, where m is the slope. So the slope of this particular line is the slope of this secant line. But what we would like, again, what we would like is the slope of the tangent line. So a tangent line is a line that only touches at 1 point. So maybe if I could draw that maybe a little bit better here, we could have a line that touches only at that blue point, and that looks pretty good. So we want it to pass through only 1 point. But we need 2 points to define a line, right? So we use secant lines. Secant lines contain 2 points on the graph. Of course, the slope of a secant line we can find by using exactly those 2 points that are on the graph. So slope is rise over run. So the slope m of the secant line is given by the rise would be a couple different ways that you could write this, but we'll call it f of a minus f, actually, no, let's do f of x minus f of a. The order doesn't really matter here, as long as in the denominator we match x minus a, right? So f of x minus f of a gives us that difference in height. Now in this one, that would be positive. In other cases, it might be negative. That's fine. We could certainly have a negative slope, but we need to match the x minus a. So this is slope of a line containing those 2 points. Easy enough. So again, that's a secant line. Now, if we wanted to, if we wanted to find the slope of the tangent line, what we're going to do is we're just going to go ahead and take this point right here and slide it closer and closer to the blue dot where we want to find the slope of the tangent line. Because as this black dot moves over, it's going to become a better and better approximation. And when we take the limit, that limiting value, the value of the limit rather, is going to be the slope of the tangent line. So we're simply taking the limit here now. So we take the limit as x approaches a of f of x minus f of a divided by x minus a. And that is exactly the slope of the tangent line. Excellent. So that is the basic idea. We haven't said differentiation yet, and we will do that in our next video. So thank you for your time and attention. I'll see you guys back in the workshop in just a minute.